All right, let's continue our story about series and Taylor series, etc. And when I wrote up the notes here, I went in an order that I kind of went, you know what, I'm going to go in a little bit different order because all that work that we did up here, especially way up here, all that stuff, as I live and learn, I think it's really good. This next problem, what we're going to do is we're going to find the Taylor series, and that means you're going to center it elsewhere, but I'm going to develop the formula for you too. Okay, so the problem here is saying, hey, look, I want the Taylor series, I want it for cosine, I want it centered at pi. So in a drawing, and you take a look at the cosine wave as it's moving along, well, this is pi right here, and what we're seeking is a curve that goes to that point as usual, and it's a polynomial that's mimicking cosine that way, like I showed you on Desmos on the previous video, okay? So the whole thing changes. If you're going to center it at a instead of 0, your polynomial, let's see if this makes sense to you, your polynomial will be of the form, well, there's going to be a constant in front, call it C0. There's going to be another constant, and it's going to multiply not with x, because if I plug in a, I want to get, all the terms to go to 0. So instead, we're going to plug in x minus a in general. Okay, so when I plug in p of a, I get C0 only. Watch, p of a is equal to C0 plus C1 times a minus a, gone. All of them are gone. You understand? So we're building it differently. We're going to go C2 times x minus a squared, and then C3 x minus a cubed plus etc. Okay? So with that in mind, okay, what we'll do is we'll build this from scratch, almost like building like the quadratic formula, which I did for another class. We're going to say there's a function f of x, and what we want to know is what is f of a. Well, I don't know what the function is, just call it f of a. But over here we have a polynomial p of x, and I just wrote it up there. There it is. So p of a, right, is equal to C1. And what we want is that these two guys to match up. And it tells us, guess what? C0, oopsie daisy, jumping ahead of myself. C0 should be f of a. Okay, I'll slow down. All right, you go to the next guy, you go, here's f prime of x, we find it. And then what we do is we plug in a. All right, so what does p prime of a look like? That's what we want. We want them to match. So the first thing you got to do is find p prime. So p prime of x is, looking up here, the C0 disappears. What happens when you derive that guy? You just get C1. And the next one is 2C2 times x minus a to the 1, and then plus 3C3, and then x minus a to the 2, and plus whatever other terms you want. So that tells us that p prime of a, watch this, 0 and 0, because you're plugging in a, is C1. So that means you want f prime of a and p prime of a to match. That means, guess what? C1 is equal to f prime of a. You'd think they all do that, but you know they don't from the previous lecture. As soon as you go to the second derivative and you plug in a, doing it over here with the polynomial, you get p double prime of x is equal to, goodbye C1, I'm looking here, but then you still have the 2C2, and then you have a plus 3 factorial C3 x minus a, and then you have plus 4 times 3 C4 x minus a squared, and I just brought in a new guy, huh? So p double prime of a is 2C2. And what does that tell you? We want these to match also according to this strategy. So what does it tell us about C2? Well, C2 is equal to f double prime of a all over 2. Do one more, okay? Because we're building this formula, right? So this formula we're building, by the way, once you master it, you can do any Taylor series you want. Okay, so f triple prime of x, when we plug in a, we get whatever we get. But over here, p triple prime of x, let's do that now. It's some calculus. 2c2 is a constant, goodbye. We end up with 3 factorial c3, that's it. And then plus 4 factorial c4 times x minus a, and etc. And when we plug in p double prime, triple prime, we plug in a, we get, remember, all these guys go to 0, we get 3 factorial c3. And we want these to match. And that tells us that c3 is really the third derivative of the function evaluated at the center, a, divided by 3 factorial. And I think, oops, what happened? Oops, no. I pushed a funny button. I just want to, okay, I think that does it. Okay, good. So, where are you now? Whoa, okay, this is where we are right now. Very good. There is a formula that is developing, okay? So, our polynomial, all of these coefficients are going to be replaced by what we're finding. They're all being replaced. And so our polynomial has the following form, and you're going to want to memorize this. This is a Taylor series centered at A. It goes like this. Well, the first coefficient, the first constant is f of A, whatever f of A is. So if you're doing, cosine, what we're going to do is cosine of pi or whatever, then you're going to get a -1, okay? Then you're going to go plus f prime of A, and then guess what? See this guy up there? Times x minus A. And then plus, now, it gets more interesting, f double prime of A divided by 2, or call it 2 factorial, x minus A squared. Go to the next guy. Do you see it? C3. Remember C3 is this guy? It is f triple prime of A divided by 3 factorial times x minus A to the third, and on it goes. Do you see the pattern here? It's really important that you see the pattern. This has got a bunch of 2's. It's got the second derivative. It's got 2 factorial, and it's got the second power. And this is a bunch of 3's. So that pattern is really cool. All right, so now using this as a template, we'll go up here and we will do this problem and we'll do another problem, and this video is over, okay? So this time it's f of x is cosine, we know that guy, and a is pi. So this is a way you can do it pretty quickly. So f of x is cosine, and a is pi, and we're going to build the series. And what we're going to do is find the derivative values. We're going to find these guys. Really, when you're doing this, let me do this in red. You got to find this number, you got to find this number, you got to find this number, you got to find this number down the line. But the rest of it stays the same. It stays, you got x minus a, then you have x minus a squared over 2 factorial, x minus a cubed over 3 factorial. That's how it builds. So really all we need is this. We need to go f of x is cosine. F prime of x is, gosh, we've done this a bunch, huh? Minus sine. F double prime of x is minus cosine. And f triple prime of x is back to cosine again, isn't it? Oh, back goes to sine. I was in a hurry, wasn't I? And then what I do is I tell whoever will listen to me, hey man, all you got to do now is go, well then, f of pi is what we're looking for, because that's the center, and that's what we want to find, is equal to cosine of pi, and of course that's -1. Don't forget that number. F prime of pi is negative sine pi, which is 0. I'm going to keep that number under wraps too. f double prime of pi is negative cosine of pi is a double negative is 1. And then finally, f triple prime of pi is, again, sine of pi is equal to 0. Now, I'm not saying you stop there. You can keep going and going and going. But let's see if we can figure out a pattern to this. You see, the thing about these in series is if I can see the pattern, I can tell you what the polynomial is as far as you want it to go. So our particular guy, now this is the important part, is fitting it together. The first thing is f of a. For us, it's f of pi. Guess what the first number is? It's negative 1. Okay, the next one is plus f prime of a, which for us is f prime of pi, which is 0. We don't need to write it, but I will. X minus, what is a? Pi. That's what you put there, pi. Okay, so the a throughout for us is pi, wherever you see it. That's how it goes. And then we're going to go plus the next guy. Let's see. We need f double prime of a, which for us is f double prime of pi, which is actually 1. And then this is x minus pi, what, squared? The next one is f triple prime. F triple prime is 0, so it's going to go plus 0. What did I forget? I forgot my guy here. I forgot over 2 factorial. This next one would be 0 times, let's say, x minus pi cubed over 3 factorial. Okay, that's not saying much, is it? This is what we're getting. But you can actually fill in the blanks. You go, well, the next one, I think it repeats, doesn't it? Yeah, it goes back to this guy. So it goes, that's because it's cosine. So you get a minus 1 over 4 factorial, and then x minus pi to the 4th, and then plus, and on it goes. Okay, so let's clean it up a little. And what we have is that cosine of x with, where a is pi, you're centering it there, can be approximated by negative 1 plus, and here we have, let's say it's, I'll write it this way, x minus pi squared over 2 factorial minus x minus pi cubed over 3 factorial and plus, and so on and so on and so on. Okay, so building it from the formula is the best way to handle this in Calc 2. Let's do one more, lengthy kind of video, but let's do one more. Then we'll have one more video that deals with applying this stuff, right? Okay, so here is what I just said. This is the handy definition that you're going to want to remember. The thing that's missing is that it's centered. They give you a number, let a. Look at this example. Here's our function. It's a straightforward polynomial this time. F of x is x to the 6th minus x to the 4th plus 2. We want it centered at 2. Okay? My process is this. I simply go, I'm ready to go. First, I'll find the derivatives. I've got f of x is this guy. But then I start deriving, and boy, I'm glad this is an easy guy because it's going to be 6x to the 5th, right? Minus 4x cubed, and that's it. Keep going. Let's go all the way until it disappears because it's a polynomial, and that's what's going to happen. So we get f double prime is going to be 30x to the 4th. Okay, and then minus 12x squared. I'm going to keep going. F triple prime is 120x cubed, oh boy, minus 24x. One of them is about to drop off. The 4th derivative, let's keep going. That's a v. Okay, we have 360x squared, 360x squared, minus 24. How about the 5th derivative? Well, we're going to lose the 24. We're going to get 720x. And then lastly, the 6th derivative. And it is 720. And of course, after that, it's just zeros on down the line. With that done, now we can go, what is f of, what was the center again? 2. So f of 2 equal to, oh boy. I didn't do this. I'm doing this from scratch, so these big numbers are probably going to scare me. I'm reaching for a calculator now. But anyway, what I've got here in this case is, let's see, if I plug in 2 here, that's going to be 64. Let's do it. 64 minus 16 plus 2. So what we're getting is 66 minus 16 is 50, I do believe. So that's the first number in our polynomial. In fact, I might just kind of march down this way. F prime of 2 is looking for F prime. There it is. It's 32. It's 6 times 32. I know the powers of 2 pretty well. Minus 4 times 8. So whatever that turns out to be, 180, 196, I think, minus 32. So we're getting 164. 164. Okay. Don't forget that guy. And second derivative, does it get any easier? Probably not. It's equal to 30 times 16 minus 12 times 4. So that's going to be 480, I think it is. And then minus 48. So we're getting 440, 432. This is a strange problem. I pulled it out of the book, I believe. Triple prime of 2. Let's see. It is 120 times, see, I'm looking up at the functions we have, times 8. And then minus 48 again. Did that work out okay? Yeah, it's by 2's, right? So 48 again. So we got 960 minus 48. So we're getting 912. It'd be embarrassing if these numbers are wrong. Oh, well. Fourth derivative of 2. Okay. Fourth derivative is 360 times 4. Okay. Minus 24. I'm getting tired of doing this in my head. So let's see what happens. Don't check it. Don't email me if these are wrong. Times 4. I have got a sensitive ego. So minus 24. I've got 1416, so it's equal to 1,416. What's this going on here? I don't know. Let's find out. You've come this far. You must go on, as he says. So the fifth derivative at 2. Okay, so where's the fifth derivative? There he is. It's 720 times 2, which I'm not going to do it. 720 times 2 is 1440. I should have known that. 1440. Okay, and then finally the sixth derivative at 2. Well, you know what happens after that? He's 720, and then the rest are just gone. Okay. Wow. Why did I do that? I don't know. But here we go. Here comes your polynomial. You ready? Our polynomial, in honor of Taylor, I'll call it T of x. And so the first number is 50. Okay. And the next one is 164, apparently. 164. Guess what? X minus 2. Right? And the next one is 432. So plus 432 over 2 factorial x minus 2 squared. Next one is 912 over 3 factorial x minus 2 cubed. And the next one, 1416 over 4 factorial x minus 2 to the 4th. And how many more? A couple more. So we'll say plus 1440 over 5 factorial x minus 2 to the 5th. And lastly, plus 720 over 6 factorial and x minus 2 to the 6th. All right, I'm not done yet. I want to know what those numbers are. So what we're getting for t of x, it's a polynomial game on this one. It's 50 plus 164 times x minus 2, and plus that's going to be 216 times x minus 2 squared, and then plus 912 divide by that. So 912 divided by 6 is 152 times x minus 3, x minus 2 cubed. Okay, you can stop watching, but I'm having fun. And then I'm going to go 1416 divided by 4 factorial. I can't see my thing. That's going to be 24. So 59. So plus 59 x minus 2 to the 4th. And then 1440 divided by 120 is that guy, is 12. So plus 12, x minus 2 to the fifth. And lastly, 720 divided by 6. Now I'm going to go to the probability button and pull out that factorial. And I got 1. It is 720. I should have known it. And then you have x minus 2 to the sixth. What a weird, strange problem that is. But look at, this is the thing about this that's pretty interesting. It's just a game in math. But look, we came up with a function, a Taylor polynomial for x to the sixth minus, okay, so this is equal to x to the sixth minus x to the fourth plus 2. All of this, if you were to multiply that all out, amazing stuff. Thanks for listening.